Hello, welcome back to the video lecture series for Introduction to the Art of Programming using Scala. In this chapter we've been looking at other types of collections. We've seen the buffer, the set, and the map, and we've looked at them each individually. I want to use this video to briefly start pulling those into our project. We have a number of places in our project where we've used lists primarily in a way that probably was not where the list was not the ideal solution. And so in particular, some places a buffer will be better, some places a map will be better. And so I want to go look in the project code and see where we can make those changes and make those changes at this point. So here we are in the main client. Actually, let's go ahead and let's go through and find things that where we don't have collections, and we can go ahead and close those out just so that I can more easily see everything that's up here. So let's start with the client main. We have a list view, we have a list view. Those are fine, they're storing things however they're supposed to. We have a frame, and at least on the surface everything looks good here. This really didn't involve any collections itself. The collections start being in the server, and they are all over the place. So for example, here we have semesters and users, which are both var lists, and hence they get colored red. Now we could have made them vals, except for the fact that down here we are adding things to them, and while technically I'm not adding things to users in this code, we know we're going to have an add user method at some point. We have to be able to add users to our system. The problem is that you can't add on to a val list, and it's hard to add things on. You actually also can't add into a val array either. But now we know of a different collection type that will work very well here. And so if we import collection.mutable, we can change these to be mutable buffers. Okay, and then instead of doing a cons equal, we'll do a plus equal down here, and we save that code, and this is now happy. Okay, now actually as I think about this more, the users, so semesters is just a sequence. Users could be a sequence, but let's go look at how we deal with users. And so you probably notice that when you're on something, it gets highlighted down below, and you can even see it on the side. This is our one place where we're using users right now. And the main operation that we have here is we're doing a find to look for a user in this buffer. There's a faster way to do this. Find is order in. It's going to run through all of the users individually, and so for that reason that's really not quite the ideal way to create our users. It would actually be better to have our users be a map. And so I'm actually going to go with a mutable map. The immutable map would once again prevent us from, especially if we make it a val, would prevent us from adding things in. I would like for this to be a mutable map that goes from username to the user instance itself. And that's going to change our valid user down here. It will also change our how we're referencing this below. In fact, it will make that more robust. So find goes through and linearly looks for something. It might be tempting to just do users sub name, okay? Because users sub name will give us back the instance of whatever it is that we're looking for. However, if you do users sub name and the thing isn't there, you get an error. There's a method in the map called get, which basically does the same type of thing that a find would do, except for the fact that find is technically more powerful because it takes an entire function. This is like using the apply, except it gives you back an option. If you use the apply, which is basically what I'm doing here, if you do that and you get back and the key that you're looking for isn't there, you get an error. If we do get, instead of getting back just an instance itself, we get back an option of an instance, and that allows the rest of our code that we had written already for find to work nicely. And this will be faster because our map structures things and gives you fast lookups by whatever the key is. So this will be much more efficient. It's also going to make this more robust down here. So right now I hard-coded in the number 1 because JDoe was the second user that I had in my users. Well, obviously if I had changed anything up here, this stops being JDoe. By using the map, I now look things up instead of by their index, by the username. And now this will work fine and will always give us JDoe as long as there is a JDoe in the list. This would still be an error if that weren't there, and this will wind up being removed later on. What other collections do we have in here? Well, our semester keeps, or our server keeps track of a bunch of semesters. Our semester also has one of these var lists, and so I would really like basically all the var lists to be changed to mutable buffers. And I will import collection mutable again. How are we going to add things into here? Let's go ahead. Okay, so because it's a val and not a var, it will always be equal to either this mutable buffer or the one that's passed in if a value is provided, but we can alter that mutable buffer by appending stuff to it. In fact, this is one thing that I kind of like about using the buffer. With the lists, we were always prepending, and so especially when it comes to things like GUI elements, when you add a semester or whatnot, no one expects the new semester to appear at the top of the list. It's just kind of general expectations that things appear at the bottom of list displays, and so this will actually behave more in the way that people are expecting. Our course also has some var lists inside of it, and so I want to do the same thing here as well. It's worth actually discussing for a second how good of a choice this is, and if there's anything else that we should be doing. And in fact, I'm going to make the argument, we'll come back in just a second, after I make these changes. I will wind up making an argument that says that we need to be a little bit more careful with the mutable buffer. I like the mutable buffer. It gives me what I want for this situation. However, it has certain risks associated with it. So for example, the adding a student, I do a plus equals, does exactly what I wanted, it appends the student at the end. And it turns out that's an efficient operation. Now, how is this potentially risky? Well, the reality is that if you set up a course and you pass in a buffer, remember you're getting a reference to a buffer that was created someplace else in the code. And what that means is that because you're getting a reference to something that's mutable, that outside code could also still have a reference to that mutable value. And then we don't have the protection that we are controlling all the access. In other words, like you wouldn't have to call add student they could take their reference to the mutable buffer and add a student into it. And that is something that we definitely want to prevent in our object orientation. We don't want people to have access to our private members. I mean, we made this private for a reason. But by allowing someone to just pass in a mutable buffer, we've effectively broken the privateness, because whoever creates this course, wherever in the code the course is created, they potentially, if they don't use, now if they use the default, then this isn't a problem, but if they pass in a value here, they keep a reference to that, and they effectively have a backdoor inside of our code. And this wasn't a problem for the main, because it makes its own buffer and everything's fine. But it was a problem for the semester, and it is a problem for the course as well. So how could we get around this? Well, what I'm going to do is I'm going to create a temp courses, and I'm going to make it a sequence of course, and I'm actually going to go back to nil here. And then one of the first thing that happens in here is private val courses equals mutable buffer of temp courses as an argument for what it's going to be wrapped around. Okay, so what's happening here? When you pass something in, like this temp courses, and you put neither val nor var here, it's just an argument that's passed in, and it can be and will be forgotten as soon as it can. It actually does not become a member of the class. You only get a member if you have a val or a var there. So temp courses isn't here. It is, as the name implies, a temporary. Notice that I'm passing it in as a sequence, and that's some high-level super type. So this, whereas if I force them to pass in a mutable buffer, they have to pass in a mutable buffer. It either has to be an array buffer, or a list buffer, or whatever subtypes of buffer, but they couldn't have passed in a list. They couldn't have passed in an array. And quite honestly, I should allow them to pass in things like lists and arrays. Those are quite fine. I don't care what type of sequence it is that they're giving me. But once I get that sequence, I don't want to remember their sequence, especially if their sequence happens to be mutable. I definitely don't want to remember their sequence. Instead, I want to take it and create my own version of the sequence that then I'm going to use going forward. So let's go ahead and let's make these types of changes in courses as well. Except this will be students and instructors. Temp students and temp instructors. We come up here, these are no longer private vals. And I'm no longer going to make them mutable buffers. I am just going to make them sequences. Turns out that this part also makes it a little bit more efficient. Calling mutable buffer with an empty with empty parentheses actually has to go ahead and create a new object for me, which I am then immediately going to throw away. By making this a sequence, and because list is a subtype of sequence, I can pass in nil here. And nil is an object that already exists, and because it's immutable, everyone gets to share the same nil. So I get a little bit of efficiency off of this as well, and I also remove that possible safety problem where I got a buffer from the outside world. So that is a quick look at how we can integrate some of these collections, some of our new collections, into our project. We've put them all together, made it so that everything, I believe, is happy. Let's go ahead. I guess we really should be, to be complete here, go ahead and run this. And let's say we're going to log in as our super user. Sure enough, everything works the way that we had it when we left off last time. There is one thing that we forgot to do last time. I'll leave a to-do there. because we're not actually swapping the panels, but we won't fix that in this video. We'll come back and play with that probably in a future chapter, after probably sometime in the next chapter when we start adding some more functionality and we want to have the ability to do multi-threading. So that's it for now. See you again soon.